In our previous video, we developed this template, which we're going to be working from now. So you can go to a copy of this, the link will be in the description, and you'll be making these modifications to it in order to simulate more realistic projectile motion. Let's review what this is doing. When I click on the flag, I'm going to reset the size and position, go to my initial position, define some variables, and then repeating until x is greater than 140, I'm going to change my x position and change my y position, updating each using the current value of the velocity. Let's take a look at what happens there. Remember that the velocities are vx equals 30 and vy equals 40. We know from previous experience that that's launching at a 53-degree angle above the horizontal. So one thing I notice we're failing to do is changing the y velocity. We know that gravity exists. So we want to be changing Vy. Remember, it changes by the product of two things. Its rate of change, which is the acceleration due to gravity stored in our orange variables tab here, which we call g, times how long it's been changing during this trip through our loop, this lighter orange repeat until structure. Let's take a look at what happens now. Clicking on the flag, we see much more realistic behavior, although I don't know if I want this to stop at this height. Let's see where it starts and where it ends. It starts near that hay bale, and it ends much lower. We'd like to have a launch on level ground. So it looks like we'd like to stop on a different condition. I'd like to stop not depending on how far I travel horizontally, but I'd like to stop when y is less than my initial launch height, which I see up here is -80, so we'll repeat until y is less than that, grabbing our y variable here and inserting that. That looks much more realistic, much more reasonable. Now remember, one thing I'd like to know is how far the ball traveled for these initial conditions, this launch angle and launch speed. So let's go to our looks tab, the purple one here, the purple dot, and go to say. I see say hello here. But hello is not what I'm going to say at the end of the program. I see my pill-shaped oval here. I'm going to go to operators and say a mathematical expression. It will be the difference between my final value of x and the x I started at, which looking up here, I see that my x started at -140. So x minus -140, note that that's x plus 140, and let's check. So this is telling us that we've traveled 246 meters, launching at some initial speed that takes us 30 meters per second forward to start and 40 meters up to start with a gravitational acceleration of -10. Remember here that we've been using the initial y velocity at the beginning of each trip through this lighter orange loop, and we discovered in our previous videos that that was not the right thing to do. We want to use not the initial velocity, but the average velocity. But I know in these two factors here, I want to have 1/2 gt squared, 1/2 g times dt. We need some more multiplication there, so I'm going to put another multiplication into each of these, and I regret how small the stars are in these multiplications. But if you have a hard time seeing, it's the third green oval is multiplication. I want to have 1/2, which is 0.5, times g times dt. This is dt squared, so it's dt times dt. Let's take a look at that. Remember, we were seeing 246 meters with these initial conditions. We're going to launch again. And now I see that there's somewhat of a difference, 243 meters. Let's see if that changes if we make our time step bigger, changing it to 0.2 and clicking on our green flag. 240 meters, very slight difference, making it a factor of 2 smaller than the initial 0.1, 0.05. Let's try it again. I see the simulation is running more slowly because I'm taking more time steps. And 241.5 is our range now. We could have this again and see if it changes, see if that has converged with this time step. I notice we're doing a lot more computations to simulate this motion. 240.75, even smaller change happening now. I believe most of this variation now is due to the fact that there's no exact time step when this apple is exactly at the height that it left. So we're looking at the time step closest to reaching the same vertical height that the apple left from without going below that, without going below our initial condition, which was -80 for y. We can visualize this a little bit more clearly. You'll need to add a tool. I'm going to come down to the lower left here, this little blue symbol with a plus sign in it. Clicking in that, I've already done it, but you'll need to add pen, draw with your sprites. This lets us make some additional notation in our simulation domain. I'm going to come down to the pen tool here in my tool tray. To begin my simulation, I'll erase all. That's just after the flag, so I get a nice fresh canvas. And I'm going to put the pen down before I move to my new position, and I like to pick the pen up after I draw each little line segment. Let's take a look at what happens now. Beginning again, I see that now we're visualizing the arc with the default color, which is this dark blue. And it's telling us the value of the range that we've traveled.